This is R.D. Sharma solution, class 12th, chapter 6, exercise 6.3. Using determinants, find the area of the triangle whose vertices are 1, 4, 2, 3 and minus 5, minus 3. Are the given points collinear? So, area of a triangle, the third three vertices are given 1, 4, 2, 3 and minus 5, minus 3. And if the triangle area has some value, then the points are not non-collinear. But if these points are collinear, the area of the triangle should be 0. This is the concept. So what we have to do is half x1, x2, x3 you have to put in the first column, y1, y2, y3 you have to put in the second column, and 1, 1, 1 in the third column. So row 2 minus row 1 you have to do, row 3 minus row 1 you have to do, and then just open it because 2 zeros eventually you will get, and then the final answer can be negative or a positive. You will always take it in positive. Area will always be, because area is always positive, it cannot be negative. So when it comes 13 by 2, that means the points are non-collinear. Using determinants, find the area of a triangle with vertices these three. Since we have already done a question like this, x1, x2, x3 I am writing in the first column, y1, y2, y3 in the second column, 1, 1, 1 in the third column, r2 minus r1 you have to do, and r3 minus r1, that is row 2 minus row 1 and row 3 minus row 1, 2 zeros, and final answer will come. So I am skipping just because we have already done questions like that. Using determinants, find the value of k, so that the value k 2 minus 2k minus k plus 1 2k minus 4 minus k 6 minus 2k may be collinear. So half, I am taking area of triangle k minus k plus 1 and minus 4 minus k. Now why here? 2 minus 2k, 2k. In the second column I am putting the y values. 6 minus 2k, 1, 1, 1. Now let us, this is equal to 0, that is collinearity condition, right? So if you are able to do it using certain way, if you can make it easier, it's very good. Otherwise, this row 2 minus row 1 and row 3 minus row 1 is always there, right? So minus k plus 1 minus k. Minus k plus 1 minus k is going to be minus 2k plus 1. So k 2 minus 2k in one first row will remain like that. And minus k plus 1 minus k will be minus 2k plus 1. 2k minus 2 plus 2k is going to be 2k is 4k, 4k minus 2 will come. So 4k minus 2 it is. Then we have 1 minus 1, that is going to be 0. Now R1, R2 has been done. Now R3 minus R1 you have to do. Minus 4 minus k, that is going to be minus 4 minus 2k, 6 minus 2k minus 2 plus 2k. So here you get, this gets cancelled, 6 minus 2 is 4. Again 1 minus 1 is 0. So this is how we will get, and you have to open it using the third column. Half is already there, remember. But since it is equal to 0, half cannot be 0, so whatever is coming inside has to be 0. So minus 2k plus 1 minus 4 minus 2k. Here you get 4k minus 2 and 4. Okay. So let us cross multiply 4 into minus 2k plus 1 minus plus I am taking 4 plus 2k it will be, and this will be 4k minus 2, and this is going to be 0. So multiplication, whatever multiplication you will do, the final will be 8k square plus 4k minus 4 equals 0. So this is the whole multiplication. Just recheck it. Once you do it, just recheck it. This is going to be the final expression. Now just divide both sides by 2. You get, or you can take 2 common. So you will get a 4 common. 4k square plus k minus 1. So 2k square. So 2k square plus, you can do it like this, k minus 2, So minus 2k plus k. So you can take 2k common, k minus 1, k plus, oh, that is going to be, it's 4k, it will be 2k minus k. Okay, 2k minus k. There is slight mistake. I'm just correcting it. It will be 2k minus k. When you take common, it will be 2k minus 1 and k plus 1. So k will be minus 1, k will be half. Okay, there is a slight correction there. If the points these are collinear, find x using determinants. Okay, let me tell you here only. So half x1, x2, x3, you have to write it here, x 5 and 8. y1, y2, y3 will be negative 2 to 8. Then we have 1, 1, 1 as the third column. So half cannot be 0. So just you have to do R2 minus R1 and R3 minus R1. So you will get 2 zeros. When you solve it, x is going to be 3. Same thing here, if the points these are collinear, find x using the determinant. So you have to take the area of a triangle and put it equal to 0. So this is the same thing which we have to do. The main thing is rho 2 minus rho 1, rho 3 minus rho 1. This is always done. X will come as 5. Just recheck it. Using the determinant, find the equation of the line joining the points. So we have 1 point, 2 point, 3 point. So 1, 2, 3, 6. I'm taking the first part. And this is, we don't know, so we take it as xy. Now we know the area of triangle is 0 if the if there is a line or the points are on the line, or you can say 3 points are collinear. So it will be half 1, 3x you have to take in the first column. Then 2, 6y in the second column. 1, 1, 1 here. Now this has to equal to 0. So half cannot be 0, so this will be equal to 0. So you can open it using the first row, 1, 6, 1y1 minus 2, 3x, 1, 1. Then we have plus 1. It will be 3x, 6y. So this has to be equal to 0. So 6 minus y here, minus 2, 3 minus x here, and plus 3y minus 6x equals 0. So 6 minus y minus 3 to the 6 plus 2x plus 3y minus 6x equals 0. So what do you get here? So 3y minus y is 2y, and then 6x minus 6x plus 2x is minus 4x. 6 gets cancelled. So you get 2y equals 4x, that is y equals 2x. Y equals 2x is your whole equation of the line. So y equals mx plus c is the normal equation which we take, general equation, and this is that type. So the y-intercept is 0. So the second one also we will be able to do. 3, 1, x1, x2 is 3, 1, and y1, x2, y2 is 9 and 3. I hope you will be able to do, right? So similarly, x equals 3y will be the answer of the second part. Find the value of k if the area of a triangle is 4 square units whose vertices are these. So there is a triangle being given and the points are k0, 4, 0 and 0, 2. The area of a triangle is 4 square units. So half k, 4 and 0. Then we are taking 0, 0, 2. So in the second column I am taking 0, 0, 2. And of course 1, 1, 1 will be in the third column. And this is equal to 4 square units. So because the area, as we just saw, minus 13 by 2 was taken as 13 by 2. Here also it can be plus or minus. So you have to take both the options, right? So 2, you can take it on the right hand side, it will be 8. So it is 8. So let us open this. So first row we are taking k and 0, 1, 0, 1, 2, 1 will come. 0, 1, 2, 1. Okay. Minus 0 I am not taking it. Plus 1 finally. So 4, 0, 0, 2 will come. So this is going to be plus minus 8. So 0 minus 2 it will be. So it will be minus 2k plus 4 to is 8. 8 equals plus minus 8. So one time we'll take plus, one time we'll take minus. So minus 2k plus 8 equals plus 8. minus 2k plus 8 equals minus 8. So this will be minus 2k equals 8 minus 8 is 0, so k will be equal to 0, and minus 2k equals minus 8 minus 8 minus 16, k equals to just 16. So k equals 0 and k equals 8 will be the answer. Okay, there are two options here. You have to do each stepwise like this. Second also will be able to do. Okay, this is the second one. Just do it and just have a look here. Okay, this is all about this exercise. Thank you so much. Take care of yourself.